So let's go over the bell ringer. We're not going to spend too much time on the details because you should already know this. It's just kind of like a refresh of what you already know. We're talking about an inequality, right? What are we comparing? Emporium to for you. What are we trying to see? For you. When Emporium is greater than for you, that is the first thing you want to do because that tells you how to set up the problem, right? So let's look at the equation. Emporium is 4.9. I mean 94, not 4, sorry. 950, I don't know what I'm saying. Plus, yeah, plus 80, where it's greater than 7.50 m plus 120. And we're trying to see when those are bigger, right? So if you follow the 3 steps that we've been talking about for who knows how long, combine variables, add and subtract, and multiply or divide, you should be able to do this very easily, right? So the first thing is to combine variables. The variables are the ones with the m's on them. So we're going to subtract. We want to keep the variables on the right or the left. This is the left, in case you didn't know. Someone ask one more time, where do we want the variables? On the left, right? So we subtract 750 m. And I told you in some cases it doesn't matter which way the variables go. But when we're talking about inequality, we kind of want them there. Because you don't want any negatives. So, all right, that gives me 0. And you bring down the 120. You bring down the 80. And then this right here gives me 2m, right? Oh, I forgot this is m. And now we add or subtract. And for those of you who are like, I don't know what to do, you have to search for one of these, right? Look for one of these in this inequality. And it's right here. It's adding, so what do I do? That gives me 0, so the 2m comes down. That's greater than 40. Then it says you divide or multiply. So we're going to divide because it's multiplying. M is greater than 20. So what does that mean about our problem? They get to the sum of 20, but what is more important? What is the question? Yes, when Emporium is greater than for you. So now that you figure out that the x or the m is 20, what can you tell me about that number? That's when it's the same, yeah. That's the solution, that's when it's the same. But is that what my question is? What is my question? So yeah, so after 20, Emporium will be more expensive, right? Will be more higher. And I give you this thing so you can put the inequalities, I mean, not inequalities, the expressions in here. And 7.50 m plus 120. So before we said to start with whatever you find, right? With the solution. And now I want you to kind of take a step back and look at the whole picture. Do you only care about what happens from the point they meet and how they separate, or you want to see the whole thing? The whole thing, right? So in order for us to see the whole thing, we have to go back a little bit, right? So we want the 20, but we want something before 20. What can I use? 19. And then we have 20, and then we can use 21, 22, and 23, right? And we use the same numbers for this. 20, 21, 22, 23. When you do this, you'll notice that the numbers are different at the beginning. They meet, and then they start switching again, but in the opposite direction. So using your calculators, go ahead and plug in all these values and give me the values for the y. For this one? To what? 278. Okay. To what? Okay. And then I need everyone to be working on these things, not copying it from me. All right, for the other one, good. Well, by the way, you were supposed to be doing that for Bell Ringer. What were you doing the whole time? She just happened to do her job. Okay, I'm just saying for those of you like, it has to be 270, right? Oh, 0.5. All right. So I want you to notice that at the beginning, which one is higher? The first one or the second one? The first one, right, is 260, whereas the other one is 247. When they hit 20, they're actually the same. They're exactly the same at 20. But then after that, they switch. This one begins to jump really fast. Wait, no. Almost the same, but this one stays high. Do we calculate this one right? I don't think this is right. 247. Oh. 262.5. That changes everything. At the beginning, then we're saying that the second one was higher, right? And then at 20, they were the same. And then after that, the first one began to be higher, and the other one stayed the same. When you graph them, it will look like something like this. Notice how this one, ends up high at the beginning, then they reach the point in the middle, and then after that, it keeps low. Whereas the other one, it ends up low and then reach the middle and then ends up high. So that's when you graph them. We're not going to do that because it'll take too much time, but you should already know how to do that. I just wanted to bring this back as a refresher to keep your mind fresh on these things. Okie dokie. So let's go to your books. So this is the third part of our transformations. We did translation, which is lighting, right? We did reflections, which is crossing the Y or X axis. And now we're working on rotation, which is what it sounds like, rotating something, which is kind of like turning right, spinning. This is a good example of a rotation. When you see those things, what are those things called? Windmills. Well, I said that earlier, and the kids were like, what's a windmill? So I had to draw it, and they're like, that's a windmill. Maybe I just drew it wrong. But that's what they are. There's a lot of them in California as you drive along the coast. There's so many of them. It looks so cool. But anyway, that's what they are, and they all rotate basically like a fan. It has these things on them, and then they rotate at the center. We're going to base our rotation, which is a transformation that turns a figure at a given point, at a given rotation point, or center of rotation. For the purposes, or for this section, our center of rotation is going to be the origin for everything we do. Our center of rotation is going to be the origin. I'm saying it one more time, just so that you understand that the figure has to go around the origin. It cannot rotate in its own quadrant. Do we understand that? Tabari, are you with me? It's over here. What? This is when we're talking about degrees. Yes. So now, do you know what clockwise means? What about counterclockwise? The opposite, right? So clockwise is going the way the clock goes, actually. I don't have a clock here because I don't. But if I had one, it will turn to the right, correct? If it was counter, it will go to the left. It will go the opposite way. The other thing that I want to cover very quickly is, no, show you everything. The other thing that I want to review very quickly is what rotation means in terms of angles. If I have this right here, and I'm going to call this the center of rotation. Hang on, let me grab something. Okay, I gotta use this right here to give you an idea of what this should look like or would look like. Bright yellow. We're gonna start at the origin, right? I just told you that for this section, our center of rotation will be at the origin. Can somebody tell me, make a big dot. If I ask you to rotate that arrow, given the center of rotation being at the origin, 90 degrees, where would that arrow land? Where? Right on the y-axis, right? Right here. What if I said from that location, rotate it 180 degrees? On the opposite, right? This way. Yes. What if I said rotate it 270 degrees? Here, here, and here, right? And what if I say 90 degrees from that, 360 degrees from that position? So you go 90, 180, 270, 360. It is important that you see that relationship because any figure that I give you, imagine that it's attached to this thing. And when you rotate it, it has to completely rotate at the same way. So I'm going to give you another example. When, for those of you who are in the ROTC thing, it's the ROTC, what they call it, LCC, when you're marching and you're going straight forward and they say column right, and you have to turn, you step and then you turn, and your whole body turns to the right, correct? The same thing happens here. If I had a figure, for example, let's say this dude. This is a good example because you'll be able to tell what happens when I rotate. If this guy is marching, and he's marching and marching, and as soon as he crosses the set, turn to the right, 90 degrees, that has to happen. He has to rotate 90 degrees. But notice that the whole shape rotates. You don't go from here. You don't go from here directly here and not turn. It's called rotation because you're doing like a translation and then rotate. It's kind of like, let me put this on the side. Yes. Do what? We're going to talk about that in a minute. I'm trying to give you the idea of the visual of rotation. But imagine that if it was on here, you're kind of going around in a circle, right? That's what you're doing. You're not going straight down and then that way. You're actually going around it. That's called rotation. So keep that in mind for the next section when we start working on it. But for this one, let's say, let's go back over here. Am I still recording? Yes. Blah, 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 blah. We're going to work with this guy right here. So go to the following page, 346. And let's read it. Trace the trapezoid onto a piece of paper, include the portion of the y-axis, y and x axes, bordering the third quadrant. Do not cut it out. Just leave it as it is. Well, there's axis. Well, axes. There's two. Place your trapezoid on the axes on top of those in the figure. Blah, blah, blah. Don't worry about it. Then use that to help rotate your trapezoid 180 degrees. Now, if we go back to this part, And I told you that if we were here, where would I land if I said 180? Tabaria, where would I land? On the other side, right? Right here. Stay with me. Because you'd be like, oh, I don't know what I'm talking about. Okay. I know. All right. Then if you know how to do that, show me how am I going to translate the entire figure 180. Where would it land? Up. Where? Give me point R. Where would it be? Point R is right here. Where is point R going to land after you rotate it 180 degrees? -6 and 6. Right there? Okay. So not quite. Pay attention, please, so you don't lose me. When I said that you have to imagine this little guy marching from this position up, and then you hear the command, column left, return, and then this guy keeps walking again. Why? It's stupid. Oh, I did something over there. It froze. No, clearly not. And then he gets to this one, and then I said the command again, column left. And then he turns again, right? Well, if you land on that side and you turn, how many degrees are you turning? If I go this way and then I turn that way, how many degrees did I turn? 90, right? I just went a quarter turn, which is 90. If I went all the way back, then what is it? 180, which is also called about face when you're marching. So it makes a big difference if you understand these concepts, because it'll give you a visual of how the picture is supposed to look when you do that rotation. So when I tell Michael, for example, give that command of right face, which is just a command of turning right, he will turn 90 degrees. And notice that he's not just going this way. His body is changing, right? That means whatever was in the front is now facing that direction. It's extremely important that you understand those things. So let's go back here and look at this thing. We're still using 0 as a point of rotation. I'm going to use my little arrow to show you how this works. If I'm going clockwise, where should this land? If I'm going just at a 90-degree angle, for example. That's not 90 degrees. This is half of 90, right? From here to here, it's only half 45. I need 45 more, right? That's where it lands. Go ahead. It'll say 90, 180, 270, 360. I don't think it'll give you anything in between. So you know one is this way, the other one is the other way, and then it was down, or all the way around. Are you following so far? Good. It's going to get complicated, so I need you to understand these concepts very, very well. Here's a good way of doing it. All you have to do, remember how we did the reflections? If I were to reflect that across, I would just count the number of units away from the axis, from the same axis, right? If I were to reflect this across, not across, if I were to rotate it 90 degrees only, what would be the degrees that I would turn? Well, what axis will I be on? If I'm on the x-axis, what axis should I be on once I do 90 degrees? On the y, right? So I'm going to use the same thing, but I'm going to highlight the axis now. Yellow. And if I'm going 90 degrees, I must land right there. This thing just doesn't like me today. Why are you doing it? There he goes. Okay. So I should land right there, right? Here's what I do. I'm going to grab it again, And I'm going to pretend that it's right here. And I'm going to see where on that line is point R and point A. Right here, right? And right here. And let's pretend that those things, that the arrow stays painted the whole time. So when I turn it that way, where should I have the points? On this one? 2 and 6, right? Here's the easier part. If you can see that rotation, all you have to do is count the number of units from this one that will be here. In other words, to find point R, how many units is it from the x-axis? 2. That means you have to be the same amount from the new one. 1, 2. And this is R prime. What about A? 2 as well from 6. So this is A prime. What about T? 5, right? So this should be T prime. I hope you're doing that on your book. And then what about P? 5, but from the 7, right? From the 7. And that is P prime. Look, it's off. So now that I have that, now I can trace it to see if I did it correctly. Does it look right? It actually does not. It's- Hang on. It's the grid. It's not expanded correctly. Dang it. Yeah, hang on. It is. But look what happened. Because those are not perfect squares. See? They look like rectangles. Compare those to those. These are not squares, these are rectangles. Hang on. Just leave it the way it is. Whatever. Anyway, do you understand what I'm doing so far? No? Who said no? Because like yours should look really good compared to mine. All right, there you go. That should be better. No, it's easy to do it because I already know the points. So it should be right here and right here, correct? 6 right here, and then right down at 5 right here, and then right here. Good. And then the other points are going to be here, and here, and then here, and then here. And now you're going to see that it wasn't my fault, it was the paper's fault. But whatever. What else? I don't know why this looks like that. It doesn't matter. You get the point. You get the point. Hang on. So what if I'm over here, guys? What if I want to translate that one? What were the points? What was this point? R. So this is R prime. And this A. So this is A prime. And this is what? T. So this is T prime. And P. And that's P prime. So if I want to rotate the image now, the one with the primes, I want to rotate it 90 degrees. What do you think it will land? What do you think this part will be facing? This direction, right? Because you turn. So go ahead and do that on your own. Good. Okay, it seems like a lot of you got it correctly. Some of you are struggling. I'm going to show you one more time what it means. You want to see how far the points are from this axis, right? Now, if I'm rotating that image 90 degrees, where should that new axis be? 90 degrees away, right? On this side, if you're rotating from the center. If this point R prime was 2 away from that one, then it should be 2 away from the same one, right? So it should be right here. No. It's the blue. R double prime. And then T was how many away from it? 5, right? That means I'm going to go here to 2 and count 5 up. And that should be my new T. And then A is how far from the y-axis. So it should be 2 away from this new axis. On 6, is it? Right there. And this is A double prime. And then P was 5 away, but from the 7. So it should be right here. And now you have, oh yeah, sorry. Yes. It's just your. Oh. Well. That's where it's supposed to be. You crazy. All right. So you notice now that it's looking like one of those things that like a not a windmill, but the ones that you use, like little ones, the color ones that keeps turning, like the ones you used to put on your bicycles. Yeah. A what? Yeah. Yeah, and it just turns. I forget what it's called. A pinwheels. Yeah. So go ahead and rotate that 90 degrees more. You did? I said more, not up. Rotate the blue one, which is your double prime one more time. 90 degrees. All right, we're back. Yes, we is. So we're going to use black. And we're going to use, again, if we're rotating only 90 degrees, then this guy has to rotate 90 degrees, right? Yes. And we remember that basically the yellow arrow grabs the entire picture. I wish I could connect the picture to the arrow. Actually, I may be able to lock it. I didn't think about that. Let's see. Yeah. The what? They are, but I wanted to see, visually rotate it. I can't do it. It has to be like locked. I think I can lock this one. Lock it. In place. Cool. All right. I won't. Okay, never mind. There's too many things. But if that figure was that way, I could lock it together and bring. I don't know why he did that. Yeah. stupid. It's haunted. All right. So if this unit is too far away from the yellow and we just move the yellow on this side, then it should be too far away from the new place, right? So 2 right here. This is R triple prime. And then this is right here would be 4 more right there. And that'll be A triple prime. And then you go up and it'll be 1 more. 5 right here, right? P 3 times. And then this right here, which is T. There we go. Now we can connect them. And now we have a little wind something. Pinwheel, yeah. I'll forget. So if you notice, it's like connecting these guys to the. Why does he do that? I'm so over this board and his uncoolness. All those points should be from the same distance. I don't know if that would work, but actually that sounds like a good idea. Let me try to see if like a circle would work. Does it touch all the points? Yeah. What about the next one? Yeah, it touches all the points. And the next ones? Yep. It touches all the points on the A's. And the last one should touch all the P's. Yeah, you're welcome. Now you can see a perfect rotation. So if I were to rotate the entire thing, they will all stay inside the circle and basically rotate in order. This is the coolest thing ever. Wow. Yeah. I'm so proud of myself. What? Why? The smartboard is not smart if I don't use it. Bam. Okay. The other thing that I wanted you to understand that actually, how can you prove to me that those are or are not congruent, all of them? That's one way. What's another way? Not necessarily. Where are you going? You have like 4 minutes. You need instruction. Did you reflect? What is it? Rotation. We simply rotated the red one to the green position, right? It's the same thing. We just rotated it 90 degrees. And that one and so on and so forth. So basically, we just rotated all the way around. Because you guys are moving and have extra homework. No, I see people moving and putting their stuff away like it's time to go. The bell does not dismiss you. Oh, I dismiss you. I'm just kidding. But notice how these will be the same thing. They basically rotate. If I were able to grab this triangle and just rotate it all the way. It's this one. They were the big mouth kids. All right. I love them with all my heart. So I will give you extra credit. Listen up. You all want this extra credit. I will give you extra credit if you can create, if you give me, create one of those Cartesian planes. Teaching. Teachers, please lock your doors, and when the tardy bell rings, which is when the second bell rings, please do not allow people back into the room. We'll come around and pick those keys. Anyway, so if you can create one of the Cartesian planes and create a really cool figure, I don't want a square or a triangle. I just want a really cool figure with points on them, and give me a rotation on each 90-degree angle, colorful. I will give you a lot of coupons for that one. Do not create it from Google on your own. Make it personal. Yes.